Slice. Preview. Maybe 2 is our magic number. What do you think? We'll try 2.
Was napping.
Oh, sorry, Red Hat. Okay, 2 looks like a magic number, so let's give 2 a try. Let's see what 2 does. And let's see what my little printer can do. Now, believe it or not, this is actually kind of stressful on this little printer because we have some 1mm thick parts. We have some 1/2 millimeter thick parts. And we have gaps with clearances all the way down to 1/4 millimeter. So if the printer's off by more than 1/4 millimeter, the parts will not, they'll drag. They'll have to be filed down or sanded. They won't be able to have the clearance. So this is kind of like a little stress test also. So let's see what this little printer can do. Glad you could join us, Red Hat. Let's see. Let's export. Now, I always use a thumb drive, and the reason why is because I have way too many things connected up to my USB ports.
Hello, Repod.
I have way too many things connected up to my USB ports, and so I always have everything connected through I use a USB, well, not a USB, a SD card. So I always just use a USB card and just put it in there, because if I wiggle my computer wrong and it just so happens to jump my USB hub, then it'll shut the whole printer down and everything. So I just don't do it that way. Later on I'll probably update stuff and get a wireless and everything, but for now that's just what I do. Okay, so the SD card is inserted. Before every print, not every print, but before this print, because I actually have aluminum sitting on top of this hot plate from all the grinding and sanding I was doing from when I was working on my printer. I'm actually going to take a little bit of rubbing alcohol and clean the hot plate off. So this is just regular old rubbing alcohol and paper towel, and it says actually up to temp right now. This will be the first print with the new Bowden extruder, with the new Bowden tube, I should say. Now, many of you guys will probably notice a couple things about my printer that is backwards from what you probably hear other people with their printers do. I run a floating printer. Everybody else makes their printers rigid. I do the exact opposite with mine. All mine is loose. All of my printers loose. Let's see if it'll get started here in a minute. Let me get some not Q-tips, tweezers also. For 2 reasons. I worked in a plastics factory for years, and I didn't necessarily work on these, but in a plastics factory I found out a couple of things by working there for many years. And one of them is the tighter your tolerances, the greater your errors. Now, if you're doing machinery, you want tight tolerances because you need like aero grade engineering. You know, you need a high spec tolerance. But for plastics are a flexible medium, kind of like water, and so. Okay, we already have a problem. I think. Yeah, it did not zero out, I don't think. No, okay. Okay. So it did find 0. I thought it zeroed out and didn't find a bed. Okay, so it's printing. So by using a floating medium, you allow the plastic to find its own spot. Now you can't see anything because the print head's right in the way. Great. Let's see if I can do some adjusting here. Hold on a minute. I'll see what I can do about that. Yeah. Just a minute, I'll see what I can do, guys. Let me turn this off so you guys don't get dizzy, I hope, and turn this back on. See if I can find somewhere to put this thing. That's a little bit better than just staring at a fan the whole time. There we go. So generally I have better luck with it being a looser system than what I do with it being a tight system. Having said that, it might just all go haywire on me right now. I don't know, but generally speaking, that's a fact. Let me get off of here.
What is the basic settings? Temperature, speed, filament.
Okay, we can go look at that right now. Alright, so, well, that's printing. Let's go look at... The filament is 1.75 and the temperature is 65 on the bed. I always run a heated bed because I put nothing on the bed of my printer. I just running straight Captain tape. And the extruder is 217 for this filament. When I change filaments, then I whoops, camera fell. Then I reset the filament. I run a filament test and reset it to the filament's preferred settings. There we go. There we go. And so I run a filament test for every filament that I have. And the reason why I run heated bed again is because I put nothing on. I put nothing on my bed. It's not glass. It's I don't have any spray adhesive or nothing on it. I just run straight Captain tape and alcohol. I've dropped my retraction down quite a bit. This is my first test with the new Bowden tube. And so I've dropped, this is my first test with this retraction. This retraction is, I think, 4 or 5. I normally run about a 15 retraction, but I have the The tube I had on it before was a 30 inch tube, a 24-inch tube. There we go. I forgot I have a whole nother cam here. The tube I had on it before was like a 24-inch tube, and now I'm running I want to say an 11-inch tube. So I cut the tube in half, and I switched to the new Teflon tube. So I'm hoping that that's going to improve my retraction rate. I didn't have any problems with retraction, to be honest. The only reason why I changed it is because I got tired of my little motor having to retract all that much tube every time it would do a retraction. You know, it would just so I got tired of that, so I thought I'd take less strain on the motor. Let me scoot this back over here. But these are my settings. Of course, I can go through any of my layer settings if you'd like me to. I'd be more than happy to flip through the tabs. Just let me know what you want to look at. I just dropped my first layer height down to 0.1 millimeters. I normally have it at 2 millimeters, or 0.11 millimeters, I should say. So I'm actually pressing it down on the bed a little bit closer now than what I normally do. For the simple fact is my room's kind of cool right now. My room is at, let me look. The room I'm in right now is at 60 degrees. So the colder the room is, the closer to the bed I put the filament. If my room's a normal, you know, let's say 75 or something like that, then I will put my first layer height closer to around 15 millimeters, something like that. If my room's colder, then I press the filament closer down onto the bed. So that's one of the only things that I change regularly, is my first layer height. I'm printing at 65 millimeters speed on average. My fan just kicked on. I do not kick my fan on the first layer. I think it waits till the third layer before my fan kicks on. And I run a LV fan, high velocity, low velocity, high viscosity fan. It has a low amount of air pressure, high amount of airflow. Has a huge duct, but it basically cools my printer head off by nothing. I can run my fan 100% and it will not cool my filament head off at all. But it does cool a large amount of the plastic very quickly. So I can usually get pretty good bridging out of it. It's an 80 millimeter fan, by the way, in case you was wondering. That's a full 80 millimeter computer fan. Now, to all the guys out there that, oh, let me save this. We'll move it up to the 1.0 because we're actually printing it. Is this saving? It doesn't look like it's saving. Yeah, it saved it. Okay. Okay. So all you 3D printer guys out there, do you recognize this print? Overhang test print. Do you guys recognize this or not? Have you printed one of these before or seen them printed before? Okay, it looks like I'm getting some mushrooming on the corners. Okay, well, do you print any test prints at all? Do you print, I mean, is there any prints that you do print for test print? And I am getting some corner mushrooming too. So far it's just on the... No, that's on the actual print. So far it's on the actual print. It isn't
but
bad.
I know what is that for.
Okay. So, do you print any tests at all? Do you just print? I mean, do you ever print any kind of tests for your printer? 100 by 100 cube or 10 by 10 cubes or anything for a test print, or do you just print what you want? I mean, surely you print some kind of calibration, don't you, or do you not?
Cube test.
Okay, so is it 10 by 10 cube or 30 by 30 or 100 by 100 or what? What kind of a cube do you print? A hollow cube, a solid cube?
Some retraction test, cube 10x 10 mm.
Okay. Okay, because let's see, can I move that over any? I can't. You got like I mean, of course they have stress tests, which I don't do stress tests. But they have all-in-one printer tests and things like that. And I'm deciding to make my own form of kind of an all-in-one test. I wanted to put a bridge in it.
And little shift benching.
Okay, I was wanting to put I was thinking maybe a 50 by 50 by 50 pillar test, so 50 millimeters tall, 50 millimeters Z, 50 millimeter Y, a small bridge, maybe like a 50 millimeter bridge, a clearance test, which is like pins inside of circles. So you know how what size of a pillar, what kind of a pin and pillar you know what kind of clearance you need between the two, and a few other things all in one. And I was going to design my own, but I kind of wanted to get an idea of what other people use in their tests to see if there's anything that I should include or that they never use that there ain't no sense in me putting in there. I mean, like this is a nice little print, but there's nothing in there that I personally use. I don't know what I would use in this. It's very pretty, it's very nice, but there's nothing there I would use. I mean, it has nice circles and I can mic them, but there's no pins to put in there, so I don't know the clearance I can use. It has domes and it has a square, but I mean, that don't tell me nothing. A dome and a square. It's very artful, but I mean, again, it don't do nothing. I mean, I don't. Has a bridge. The bridge I could use. There, see, I mean, unless it's just telling you how well your printer can print overall. I mean, I don't know. Stat-wise, I don't know what it would be telling you, you know. Kind of, it's just relying upon the filament you use, really, in my opinion. From a designer's point of view, you know. Now, I do like this. I love the nickel test. I got a better one I made. Nickel test is really nice. It's very quick, and you don't have to have a micrometer or nothing, you know, a caliper or nothing to print. So I think that's what I'm going to work on. Our chain links are coming out. While I'm waiting for the chain links to print out, I think I'll work on that. So let's do, let's see. I always get my dimensions mixed up. I'm looking at the top, so...
Nickel is interesting.
Yeah, now, do you live in the United States or do you live in a different country? I always get my X, Y, and Z. Is X left and right, looking from top down right now, is X left and right, or is Y X and left and right? I always get that mixed up. Left and right now, looking from top down, would be X, correct?
I am living in Turkey.
Okay. Okay, so I got a 50 millimeter in X and a 50 millimeter in Y. Let's put 10 by 10 this way. Okay, so here's what I'm gonna do. Let me think, is there anything else I need? Yes, there is. Okay, so in this view, I need to go... Okay, so...
Jack it up.
What kind of coin do you have in Turkey that's got smooth edges on it, and do you have a caliper that you can give me the dimensions of that coin? Obviously not the smallest one, but obviously not the biggest one either. Kind of a medium-sized coin. If you can, I'll put that into this design. Okay, so this is...
I can't see anything now.
Oh. Oh, okay. Hold on a second.
I can. Okay, I check in. I am on the move. Take car matter dash.
Okay, have a good one, Katori. Alright, now can you see the software?
Jack it up.
Gotta figure out if that works. PIUG. If that works. KTORI.
18.5 radius.
Okay, 18.5 radius.
One 1.6.
Seven. Let me do a dimension on this. One 8.6. All right, and what is, let me see here.
Right.
Okay, so we got that, and it's 18.6, so let's go over here. Okay, we're giving it 18.7 because we're giving it a slight amount of clearance for the printer for defects. So 18.7 divided by 2, 9.35. No, that should be 18.7. So it should be, so that's going to be too big. Okay, so we'll have to place it somewhere else. Should fit right here. Undo that, circle. All right. Okay, so we have that centered up there.
You would wipe away my tears, so sincere, turn gray skies to blue. You won't ever change your ways, doing what you do.
Be easier just to make it again. We need it to be 10 millimeters wide. Millimeters wide. There we go. All right, so we got this here. .6 and 1.7. One 8.8, so that's a little bit longer. And 1.8, so it's a little bit wider. All right, so we have that set there. So that's there, this is here. Move this down here. Move this over here. Move this over here. Alright, now what's the coin called? And spell it out for me if you don't mind. I gotta remember that you guys have half your screen cut off over here, so I have to move everything to the left. While you're spelling that out for me, I'm going to work over here on a bridge test. Actually, no, let me work on a pin test so we can work on a clearance.
Kurus.
Kurus, okay. I don't know if I can make that S. Well, I know I can, I just don't know how. I'll try to copy it though. So give me just a second. You're gonna have inception going on, so give me a second. Well, I say you are. I don't see the... Interesting, my chat ain't connected.
Not S.
Right. Okay, I'm gonna try to reconnect my chat, see what happens. That's why my commands ain't working. Let me try reconnecting it. Give me a second. I'm working with one screen here. Fusion 360 didn't want to work right for me, so for some reason it didn't want to work right with OBS, so I'm working with one screen today. Let me close that out. Save and close that. We'll close that. We'll leave that window open. We'll pull that window up so you have something to look at. I don't know why 360 didn't want to work today with OBS. It's working, it's just not working with OBS. It would load up and you could see the drawings, but now it's connecting, I think. Okay, try sending that one more time, the Kurus, K-U-R-U-S. Let's see if it'll capture it this time. Meanwhile, I could get our music playing again. Is the print still showing? Yeah, it is. It's still showing. Okay, good.
I could swear it's been 700 degrees in here since you came in. I could swear that this room has been running out of air, and now it's starting to spin. You make me feel kind of bad, kind of good, kind of everything, yet it doesn't
What's the image at? Let's see.
You make me feel
Oops, wrong one.
wrong, kind of right, kind of anything, and I would change it if I could.
Alright, let's see if I can just copy that. And let's see if Fusion 360 is smart enough to let me just type that on there.
I could swear that I'm fainting. I think I'm losing my sight. I swear I'm hitting the
It does! Okay, well that's cool. Alright, so now let's make this object. Got a bunch to do on this one. Okay. Let's rotate it around this way. We need you. Let's do a extrude. We need you,
Nice.
you. Nope, not you. And you. Okay, so we need a big T, a little t. Okay, we need all that to come up. 5? Is that right? Am I missing something? No, that's right. 5 millimeters. Yeah, all we need is 5 millimeters tall. We don't need to waste a lot of plastic on this. Okay, so that's 5 millimeters. And that's all we need for that. Then we need to open up our sketch again. And we need this thing to come up.
It's too much, I think.
millimeters. You think 5 millimeters is too much? I'll go up 10 millimeters on this one. You think 5 millimeters is too thick? Think it should be thinner? Looking at this one, let me look. Oops, I just broke a pin off. Look at that. They have this thing. Okay, they only have it at 3 millimeters.
Okay, my bad.
They only have it at 3 millimeters, so I guess we could go down to 3 millimeters. Okay, so we'll go up to 10 millimeters on the vertical pillar. So let's undo. Let's undo again. Okay, so let's redo this again. This time we'll only go up to 3 millimeters. Here, 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 here. All right, all that. Let's go up 3 millimeters. Yeah, that looks a little bit better. Okay, so 3 millimeters. Then we want the Z-axis, this thing, to go up 10 millimeters. So you have a 10 millimeter dimension to check. So that's what we got so far. So the coin should fit through the X-axis, the coin should fit through the Y-axis. Now, this one here, the coin should lay in there flat. So what we need to do is to bring this up, and what was the coin's thickness? 1.7? I think it was 1.7. Let's bring that up, 1.7. Now the coin, if you set it down in there, if you have this thing sitting on a table and you just lay it in there, the coin should lay flush.
Dinner at 6 bear, you have an hour, my lovey.
Okay, babe. Thank you. Oops, new message. There we go. So now the coin should just sit in there flush, and it should be flush with the surface. Now that should compass your coin in X, Y, and technically Z, because that'll give you a Z-axis on the thickness of the coin. So that gives you your 3 axes all with a coin. Now we need to add a bridge. We can add a bridge. Okay, baby. That's my missus. Okay, so now we need to add a bridge. We can put a bridge across here. How long would that bridge be? From there to there is a 20 millimeter. Oh, it is. Is a 20 millimeter bridge pretty good, would you say? If you do a 20 millimeter bridge with no supports, would that be a successful bridge to you? Or does it need to be longer? What do you think? I mean, here, Let me look. I can't even read this. See, that's what I mean. The prints are all messed up. Here, I'll just measure it out. Roughly, that one there would be a 20mm bridge, would be that one right there, with no supports. So with a 20mm bridge, would you be happy with a 20mm bridge? Let's pop this print off. It's hot, so hopefully I won't rip anything apart. Okay, so I want to see how these come off, because I never print with support. So let's see how the supports come off. Oh, it's stuck on there pretty good. Yeah, I need a little bit more clearance, I think. That was the support material on that one. That was the support material on that one. Now that little bit of stringing you see around the edge, that was from the, not the raft, but the, you know what I mean. I can't think of what it's called right now, but overall it came out pretty good because it didn't really fall much from my bridging. So here's our two plates. Here's our two lips. Now that, in my opinion, is a success. Look at that. Almost fold up on top of itself. It doesn't seem to want to come apart. Alright, so that's a success. Let's try to put this little cap in. Oh, like it was made for it. Now I purposely made the cap a little bit lower so it would fit a little bit tighter, so it would have clearance, and that fit perfect. Let's try the other one. And now look at this. This is no cleaning on the parts whatsoever. I just printed it, ripped the supports off. And now this one's a little bit tight. I might need, yeah, I can see that one needs a little bit of cleaning. But for the most part, it's still usable.
It seems good.
I think this is a good print. Now, it looks like it's rubbing a little bit on the bottom. Right there on the bottom, it's rubbing just a little bit. So what can I do to fix that? I can take a little bit off of this bottom, or I can, oh, I know what I could do. I could just notch this. I don't need all that material there. I could just notch this out right here. I could just cut a little notch out of that. Okay, so that's going to be the next alteration, will be a notch. Okay, so let's work on this print that we got here. So a 20mm bridge. Okay, let's build a 20mm bridge here. We'll select this surface right there, and it flipped it on us. Which way are we going? There we go. Let's put a square pad there and a square pad here. Actually, I didn't even need to do that. Let's just do one square pad from here to there. And then we click all three and we'll bridge it up. 1 millimeter. That one's done. Now, let's get some printing done on this. So, 2 millimeters. Okay, 2 millimeters. So now we have a 20 millimeter long bridge to test. Now we need some printing, so let's go over here. Now let's start right here. And we will do, let's see, this again will be the X. We want it to say X, what is it, 50 millimeter? 50 mm. And Y. .50 mm. And let's see, now we need four. Three. Find a good spot for it there. Okay, now let's see, what else do we have? Name views? No. 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 Sketches? No. Okay. One 8.60. Let's add 18.60 Two is just too small. No, that's all right. And let's see, this one is 18.80. One 8.80. That is 1.8. $1.8.
Nothing new, and my lover's honesty, I can push it back down if
This one is 1.7.
if you want me to, 'cause we can
1.7.
and we can the stars they fall all for you. So
Alright, so what we miss? Oh, we got a bridge.
what's left to lose if we
This is a 20mm bridge. Alright, everything's understandable so far. Let's go over here. No, that ain't what I wanted. Stop sketch, go over here. Sketch right there. I need 10mm. Alright, rotate back this way, stop sketch. Alright, so let's get back to top view. Let's get some of this matched up here. First of all, did we? Yeah, we got the bridge done. Okay. There. The extrusion. 2, 3, 4, 5, 6, 7, 8. That all of them? Okay, 8 profiles. Let's go with join. There's 50. I think 50 should be good. What do you think? Everything should be raised by 50, 0.5 millimeter. All the text would be raised by 0.5 millimeter. A printer should be able to handle that, don't you think? A little bit more, 0.6.
(1.2x2).
One and a half millimeters. One 1.2.
(2.4).
You think it should be 2.4 millimeters? The text? I mean, we're just raising the text here. So you think the text should be raised by 2.4? I mean, I'm only
3.6 millimeters.
I'm only up 0.6. I mean, we're not even up a millimeter right now. Let me look. Oops, hold on a second. This is what it's looking like right now. That's a little over half a millimeter right now. You think it should be
Yes,
four
for the text.
4 times that? Okie dokie. I mean, we'll take a look at it. You'll see what we're doing here.
I confused. (0.36 millimeters).
Oh, okay, that sounds more like it. Because right now the text is actually taller than the than the
Too much.
actual print. Yeah, I thought you
Smiley
must have had
face.
something wrong with that, because I thought, man, the text is going to be taller than the whole print. I thought we must have had something a little bit wrong there. Okay, let me shrink that back down. Exactly right. All right, 0.36, 0.36. Okay, that looks reasonable. What you can do with that? That's basically a third of a millimeter. And then we'll do this one the same way. .36. All right, now we need
That little dot is so important, LOL.
Okay, so we got this plate. Now what we need to do is go back to sketch mode. Scroll back over here. And on this plate right here, we need to add circles. So let's decide on
Maybe
the circle side.
0.24 would be better.
A quarter? Okay. Alright, let me see here. So, a 4 millimeter. Let me see how big a 4 millimeter is. 4 millimeter. Five millimeter. Do 5 millimeter. 5. Now, can we do an array? How do we do an array? Array. Quantity. Okay, so we got an array of them. Okay, those are 5 millimeters there. So we'll hit OK. Now we need to make another circle. This will be 4.9. .8. 4.7. 4.6. 4.5. 4.4. 4.3. 4.2. I don't think that's going to work. I think I should actually do more than that. So let's do 4.98. Let's do 4.7. Six. Four point five. 4.4. 4.3. 4.2. 4.1. 4. There. That ought to do. Alright, so we're going to print this. And let's go here. This. What did we go up to? 3? I think we went 3. Okay. All right, now let's take all these edges and let's fillet them. Okay, now we need to flip this thing over. Alright, I don't need equal distance. There we go. All right, I think I about have it done. So here is your new test piece. Is there anything else you'd like me to add to it? I have a bridge. I have 8. Oh, I gotta mark the clearances. I forgot about that. I have to mark clearances on here. Come on, top. There we go. Okay. So, how am I going to mark the clearances?
Bridge mean co-prug.
Okay, so do I need to mark the name? Coprut. So let me change. Can I change that? How do I change that? Let me see. Hope I can change that. No. Please let me change you. Edit. Yes, it'll let me change you. Alright, bridge means Coprut. Let's go over here and grab that.
Yes, you can.
Copy. And paste. There, how's that? Stop sketch. Okay, how do you say clearance?
Great.
Because I need to mark these clearances down. I forgot to.
Can you type?
Oh. Yeah, just a second.
Clearance.
Yes. It's the space between two objects. See, it's that gap right in between there. Right in between them two right there.
For what?
This right here?
Aerolic.
Aerolic, okay. It's a space between this pin and this circle, and then this pin and this circle, and then each time it gets closer. So this is a 1 millimeter, 0.9, 0.8, 0.7, 0.6, 0.5, 0.4, and 0.3.
Aerolic.
Aerolic, okay.
Come in. I could seat you by the fire. Listen, listen. There's something I must confide. I know I said that it'd be fine. I know I made it look like it'd be alright. But I think I learned my lesson, and I'm not gonna let you out of my sight. You can call me killer, 'cause I'll bring you to the light. And it might taste bitter when you're answering to God. You can call me killer as you look into my eyes. Nothing but a sinner. You won't get away this time. You won't get away this time. You won't get away this time. You won't get away.
Do you use this program when you were building stuff?
Sorry if you said what you are building, I missed it. What you building?
Oh, on right now what I'm building is a gauge. It's kind of like a calibration for, I'm not sure what language. Is it Turkey? What language are we building this for? What kind of denomination is that coined for? 0.7. I'm building a calibration gauge for one of my viewers. And but what I started off building was, yeah, it's still on the screen, some chain link. I have a bunch of prints on Thingiverse for chain link for like printers and stuff, but they're nowhere near, well, this one's actually cooled off a little bit, so it's a little bit stickier, but still is a whole lot softer than the chain links that they have. I mean, you see how soft that is. It's still very soft, and still very loose, as opposed to, let me see if I can get one of theirs. Here we go. Here's one of theirs. And I've printed off 10 different variations of it. I mean, here, it's bent, right? I can lift up a screwdriver and it still's bent. It don't, and it's not the print, it's all their chain link. I mean, literally, their chain link will not bend. It will.
Do you have a metal 3D printer?
Not bend.
For printing heat sinks?
No, I don't. I just have a standard plastic just a standard plastic 3D printer. So I'm printing up a calibration sheet for one of the viewers now. It uses one of his coins to allow you to calibrate the printer. And this one right here, in fact, what we're looking at right now is the equivalent of a clearance gauge. So these are clearance pins is what you'll have. It goes from 1 millimeter clearance all the way down to, let's see, 1987654 on my printer is 200 cube, so it's 200 by 200 by 200. I know they got a lot bigger printers out there, but mine's quite an old printer now. It was the latest and greatest back when I bought it, what, 6 years ago, or yeah, something like that. You know, but it does fine. I've never had to print anything bigger in
200 millimeters.
Yes, 220 millimeters cubed. 220 millimeters cubed, in all three directions. Let's see. So this is a 0.6 millimeters. Oh, nope, that ain't right.
Hey, Matter.
0.6. Yes. What you up to, SWK?
Can you print something bigger but have it joining?
Absolutely.
So print individual paces and then join them.
Yes, and in fact,
I found out something that might be causing you firmware problems on your printer.
Oh, okay, that sounds cool. Yes, you can not only print stuff that is joining, but the slicer software that I use, it has a tongue and groove feature on it. So like if I grab this here, I'll see. I don't think I can do it on this screen. Let's see this screen. Does it have a slice feature on it? Where is it? Somewhere on here. I don't use it that often. It has a slice feature on it, and when you slice it, it gives you the option to tongue and groove the creation. So it'll actually make it so the two halves, you can slide them together in like a tongue and groove creation to like either just tongue and groove them, or you can glue them that way. Max fit? No. Pre-cut. Here, see, I can slice my creation in any direction I want, but you can kind of see, I mean, obviously I don't need to slice it, so it isn't going to give me the option to tongue and groove it. But you can kind of see I can slice it anywhere I want. Here you kind of get a view of it. But I could slice it at any point. I could slice my object. And then when I slice it, if it's up to a certain point, like let's say it's outside of my perimeter, see a gray box popped up. So if it's outside of my gray box area, it'll give me the option to slice and tongue and groove. And what it'll do is it'll put a, well, for lack of another term, a tongue and groove on it. It'll put like a tongue on one side and a groove on the other side of the object to the best its capability. And so the two objects, when you print them, they'll like slide together. Now obviously it's software, so it doesn't know whether that's a joint or not. You know, it don't know where the weak spots on it are, but I mean, you have to kind of slice it in the right spot. But I mean, it'll slice it and then it'll put a tongue and groove in it, and you can just slide the two halves together and then glue it or screw it or however you're going to, fasten them together permanently. But yeah, it has the free cut mode, and you can just cut it any way you want it, and just start to cut and it'll cut it, and then you can put them together. So yes, you absolutely can.
What about like dowel connection?
Yes.
Like pins instead of tongue and groove?
Yes.
Just curious what your computer will pronounce the supercalifragilisticexpialidocious.
It does pretty decent usually. Yeah, it'll do that too. I mean, of course you can do that also. And this is just the slicing software. This isn't even including the actual, what I'm working with here is the actual 3D print. So if I actually printed something for the purpose of doing that, then I can obviously just punch a hole in it and, design it for that purpose. You know, but if you just gave me a print that was, let's say, you know, 300 millimeters in length, then my slicing software alone will be able to do that, let alone the fact that, you know, if I could redesign the object and, you know, then intentionally break it in different fragments, you know, that would be an option also. So there's 0.6. Let me get my next one here. Text. This should be a point. Nope. 0.5.
Okay, he'll be back.
Okay, you coming back?
Later.
Yeah. What's up, engineering? How are you today, my subscriber buddy?
Not too much, man. I am good, haha.
I get a
There
point.
goes the neighborhood.
Oh, see, there it went. Let's do a 0.4. Now watch, I'm gonna get all these down there and realize that I'm completely off by, like, you know, 1 millimeter or something. I think I have all these numbers in the right spot, but watch, I'll have them all off or something. Something will happen.
Don't worry, SWK. I'm not going to talk too much. Folding laundry.
Oh, okay.
Ha ha ha.
Alright, and 0.3. And see, that don't sound right. 0.3 don't sound right here. I thought that was 0.2. So if that is 0.2, then everything's off. Because I brought it down backwards, so I'll remeasure it and look. Okay. Inspect. Here is 4.7, 8, 9, 10. Okay, no, that's right. 0.3.
Hey, aha.
So that should be right. Okay, good, good, good. I got it right. Okay, so now I have all my numbers on here. Let's select, oops, exit out of there. All my digits. Let's do a extrude. All my digits.
At Mater-so on ramps boards, try disconnecting the control panel from the ramps. There's a lot of reports of that making firmwares not upload correctly.
Oh, I never tried that. Okay, I definitely will try that. That's an easy try. I could do that. Okay, so let's lower this down by negative 0.5. And let's see what that looks like. Make sure I'm going in the right direction. I don't really want it that deep, but I think I'm going to have to go that deep because them buttons are rolled.
Blonde hair, blue eyes, that'll make you faint. On
Yeah, I think that'll work.
looks like trouble. Her lips so kissable and poisonous. I know she won't be good for me.
Okay, let's do it. Now I can print this up, but unfortunately, I don't have a coin to try out with it.
Me to get a chance, see the girl like her. And I won't waste that chance.
Oh, I need to flip this over too. Did I? No, I didn't chamfer that. That's a good thing. I need to chamfer this. So you know what? I need you to print this up and make sure it works all right.
Smiley face.
I give you something to do now. Ooh, that's way too big. No, I don't need that. There we go. That should take the lip off of the coin. Is that pin not chamfered? Nope, that pin isn't. I need to do that one too. Give this an equal distance. Alright, so I did it.
I can send you a 10 coin, but you are too far.
I know, right? Alright, so we got that. Well, everybody came in, but it's almost time for me to end the stream. Bummer. But we did get a chain printed out that I'll be printing out a whole bunch of, and I'll be designing some 45s, some 90s, and I'll be designing some... What else?
They were making me work today.
Oh, that ain't no good. I'll be designing some 45s, some 90s, some vertical 45s. I might even make a universal for it, so it can work not only this direction, but it can twist in I guess you call it XY, you know, the opposite direction. I might make a universal for it. I like the design though. It's very loose. It takes very little filament. This took 4 cents of filament to print, as opposed to this thing, which took 16 cents of filament to print. And I mean, this is very much more robust. Don't get me wrong, this right here is very robust. This is a whole lot stronger than mine. I guarantee you mine will break a whole lot quicker than this one will. But it don't work. It doesn't bend. So I mean, it doesn't do no good if it don't bend. So I mean, I'm dealing with 1 millimeter thickness edges, and this is dealing with almost 3 times the thickness. Yeah, 3 millimeters. So I mean, there's 3 times as much plastic minimum here versus what I designed. But I definitely will be printing out a bunch of these. I'm going to print out, well, how long is this? I didn't even see the total length of one of my links. One of my links goes for... And I'm going to put all this on Thingiverse, by the way, guys. Everything is going to be uploaded at Thingiverse. Your print is going to be uploaded at Thingiverse by tonight. I'll have a link up there for you. This is, I'm going to call it 27 millimeters long. So... almost an inch long, almost exactly an inch long. So that ended up perfect. I need about, I'm gonna say 20 inches of it, so I'll need 20 of them. So I'm gonna print out 20 of them here in just a minute. In fact, how many have I got on this plate right now? I got 2. So let's go here. And let's hit duplicate. Now 5 times 2 would be 10. So there's 10 of them. I'll print 10 of them, and then I'll print another 10 after this 10 comes out. Let's see how long that's going to take. Let's slice it. 10 of them is going to take my printer 3 hours, and it's going to use up 38 cents of material. And that's including the support material. Oh, I can't print it with that though. I need to adjust the support material just a little bit. That's what I wanted to do. Support material.
It's 5.50, baby.
Okay, I'll be there in just a moment. That's the missus. She's letting me know dinner's ready. Horizontal offset. Horizontal is left and right. Vertical is up and down. Number of layers between the bottom of the support structure. That ain't what I want. I guess I'd have to go up to 3. I really didn't want 3. It looked too tall for 3. Guess I'll go to 3. I'll turn this down to 85 for flow rate. Save and close. Now let's see what we got. Slice. Preview. Take a look at what it looks like. So this is what's fixed to be sent to the printer. Isn't that pretty? It's like a little army. Doesn't that look like a little army, guys? Look like they're getting ready to march off to battle. We just designed this on stream today. For all you guys that just got here. We just designed this together on stream today. They're chain links for cables. So they're cable chains is what it is. And it's going to be posted on Thingiverse tonight. Actually, to be honest, I think this is going to be my very first items posted to Thingiverse. Also, what's going to be posted to Thingiverse is going to be a calibration block, 50mm by 50mm by 10mm high. It uses a 10, and how do you pronounce that? I'm not sure, but 10 Kuros coin. And so you can drop the coin in and it'll see if your Z-axis is calibrated by how thick the coin is. It'll check your X-axis and your Y-axis by the dimensions according to whether the coin will slide through the slots. If it slides in perfectly on your X-axis, then your printer's basically dead on. If it won't slide in through your X-axis, but it will slide in through your Y-axis, then your printer is a little bit tight on its in-stepping, not its out external stepping, but its in-stepping. It has a bridge function to test for bridging for 22 Kurush. Okay, it has a bridge function to test for the bridging for 22mm or 20mm. 22 is the start of the print for the bridging function, and it has a clearance gauge, which I did not extend the clearance out. I need to do that for a second here. There he is. That needs to be brought up by 0.24. There we go. Got clearance gauge on it, which checks your printer's clearance ability to have a clearance Let me select this here and make this a little bit cleaner. There. Your printer's ability to have clearances from 0.03, which is, I mean, it's fairly good. If your printer can do a 0.03, you really don't need much more of a clearance than a 0.03. You're getting pretty good gears clearance at 0.03 on a 5mm hole, all the way up to a 1mm. But on a 5mm circle, now I'm not talking about a 10mm, but I'm on a 5mm circle. If you got a 0.03 clearance, in my personal opinion, you're doing good. You know, that's where scaling comes in. If you're getting 0.3mm clearance on a 10mm circle, then okay, you know, you should have that in the bag. But if you're getting it on a 5mm, then I mean, all that you're doing pretty good with that. So, and I made these like buttons, so they're rounded on the top. All you have to do is push them through. If you can push, you know, if you can't push 3 through easily, you can't push 4 through easily, but 5 and the rest of them pop out, then you know that you can have a clearance of 5. But you know, they're rounded on top so they don't tear up your thumbs, and I beveled everything in the back. So if your printer kind of mushrooms the bottom, sometimes, you know, between a heated bed and stuff, maybe a little bit of, you know, offset in your bed or something like that it'll cause your prints to mushroom. So I tapered all of the bottoms of these, so hopefully that'll kind of offset any problems you have with your bed leveling or anything like that. So it should take in consideration of any bed imperfections or anything like that. So you should be able just to print this out and press, and when you press, it should just pop right through whatever button your printer is able to clear. So if you clear only a 9 or a 9 or a 10, but you can't clear nothing else, then that's where your printer's ability's at right now. You know, through more slicer adjustments and stuff, you may be able to do better, but at the point of printing it, that's where you're at. And so this is what I designed, and with the help of our viewers. And I'm going to design another one probably next stream. I'm going to be playing some games the next couple of streams, and but I will be designing another one for my personal use. Maybe I'll use a nickel. I designed one with a nickel before, but it wasn't nowhere near as sophisticated. So, but I'll have this up. I think it's Matterdash. So look on Thingiverse under Matterdash. I'll have a link on it on the Twitch page. Look for it tonight. I'll have a link on Twitch page for it, and I'll have it up and the chains up, so you should be able to see them then. But for tonight, I think we're going to call it a night. Let's see if any streamers are on that we watch. Nope, doesn't look like it. So I guess I'm just going to let AutoHost take over. GTX Gaming, are you going to be playing or streaming any tonight? GTX Engineering? I know I butchered your name. I'm working off of one screen right now, so you kind of got to bear with me a little bit. He may have left already. Anyway, if you get a chance, check out GTF Engineering. He does a lot of Autodesk, Fusion 360 and stuff like that. He also plays games. He's a really cool streamer. We actually have quite a few good streamers in here. So if you get a chance, take a look at them. And for the rest of y'all, thank you for watching the stream. And if you have any questions, feel free to check me out. I should have a link up to these items and hopefully some more coming soon on my Twitch page. Check me out a little bit later tonight. I should have the links up after I upload them. Also, I still can't pronounce your name right. Colgin, I'll need some translation after I post this item on Thingiverse. I'll need you, if you don't mind, to do some translating for me on the description and how to use it. And then I'll post all of your texts back on the Thingiverse, if you don't mind. If you don't mind helping me out with that, I'd appreciate it. So, and then of course, if you print one, well, put up some photos. So, alright, we'll talk to y'all later. You have a fine day.
Of course.
Thank you so much.
When the night is over, my life is over.
See you.
'Cause I start thinking again.
We will see you later, and thank you for enjoying my stream with me and helping me out with this. I would have never thought of printing it out for your coin if you wasn't here, and I definitely wouldn't have known, you know, what to put everything down as and stuff. So that was all on you on that one. So I sure appreciate your help.